Alright, this is my video reassessment for velocity and position and acceleration. We'll be doing number 34, page 113 of John Batista. Start by reading the question. A relay race is run along a straight line track of length 300 meters running south to north. The first runner starts at the south end of the track and passes the baton to a teammate at the north end of the track. The second runner races back to the start line and passes the baton to a third runner who races 100 meters northward to the finish line. The magnitudes of the average velocities of the first, second, and third runners during their parts of the race are 7.3 meters per second, 7.2 meters per second, and 7.8 meters per second, respectively. What is the average velocity of the baton for the entire race? Alright. Our track will be known as Y. This is a positive Y up here. So our first runner goes 300 meters in the positive Y direction. Our second runner goes 300 meters in the negative Y direction, while our third runner runs 100 meters in the positive Y direction. Velocity 1, 7.3, velocity for 2, 7.2, and velocity for 3, 7.8. So we got to find the time for each runner. So we'll use our position update formula to find the time for each. Right, here's our position update formula. Y2 equals Y1 plus velocity times delta t. Use our algebra, and we get delta t equals Y2 minus Y1 over velocity. So for the change in time for the first runner's final destination is 300 meters up minus the 0, because that's where he started. Divided by 7.3 meters per second, and we get 41.1 seconds for delta t1. For the change in time for the second runner, we get 0 meters for the final, and for the initial, she started at 300 meters, and we divide that by 7.2 meters per second. We would get a negative time, but we're not worried about that right now, so it's just positive. Our third runner's change in time, 100 meters was the final, and the initial was at 0 meters, and you divide that by 7.8 meters per second. And then you get delta t3 equals 12.8 seconds. To find the average velocity of the baton, we have to take the change in displacement, or just the displacement, the change in distance, over the sum of delta t. So the sum of delta t equals delta t1 plus delta t2 plus delta t3. So our average velocity will be 300 meters in the positive y direction minus 300 meters because it's in the negative y direction plus 100 meters in the positive y direction. You divide that by our times, and you add these up, we get 100 meters over 95.6 seconds. So our average velocity for the baton is 1.05 meters per second for the entire race. Now, it said the average velocity, therefore we got to find the displacement. So the displacement is 100 meters from the origin. 100 meters from the origin right here. Now, if it said just find the velocity of the baton for the entire race, we'd add up the total distance, not the displacement in distance. So it'd be 700 over this amount of time. But since they said average velocity, the average, we got to find the displacement. And that's the end of my video.